Anybody missing today? Macam tak cukup orang je. Who's missing? Is everybody here?
No.
Who's not here? Remember?
Amirul Faris.
Seorang.
Izzat.
I see. Maybe they already shahid because of the fasting, don't know. So, okay. So let's start. Okay. Let's use Al-Fatihah first. I don't know what's wrong with Badrul. He's keep on connecting. The internet not good, or if you know Badrul, ask him what his problem. Because I know he couldn't hear me now. All right, so let's continue. I haven't marked your quiz. It's still in. I'm at home, so the quiz is in the office. Maybe tomorrow I'll go and collect the papers and maybe start marking. Okay, so now so where did we stop last time? Anybody remember?
Mobility and conductivity. And madam asked to find some question.
Mobility and conductivity. Okay. So what are the questions?
How does conductivity change with temperature? How does resistivity change with temperature? And how does resistivity change with doping?
Good. Anybody wants to answer?
For which question, madam?
Any question you want to answer? You want to answer all also can. Huh?
So for the
Kenapa Badrul tak turn on camera ni, Badrul? Awak nak kena kick out ke apa? Yes, Adwa. Siapa Haziq?
Madam, saya baru nak on the way balik Mahalah.
Lambatnya. Kenapa? Awak kena sambat ke apa?
Tak ada, saya tak tahu online kan. Last class lepas quiz saya balik.
Nobody told Badrul. Siapa kawan Badrul kat sini?
Saya dah nak sampai ni, madam.
Allah, sedihnya. Nobody told Badrul. Siapa kawan Badrul kat sini? Ada kawan tak?
Saya register seorang-seorang, madam.
Wah, I respect your determination and keberanian untuk register seorang-seorang. Okay, so kita apalah, baliklah dulu. So memang Ramadan ni kita buat semua online, Badrul. So tak ada kelas face to face. Lepas raya kita celebrate. Maybe we have some Somalian dishes in our class maybe. Right? Also?
Yes.
Some Bangladeshi dessert maybe. I don't know how Mukmina going to cook it. And then we have some from different states of Malaysia. Okay, so right. So now let's continue. Haziq, yes, Haziq.
Yeah, I want to answer for the first question, which is how does conductivity change with temperature? From what I have found out, when temperature increase, so both electrons and atoms will gain energy.
Atom?
Whole atom inside the semiconductor.
Okay.
Okay. And then after that, the atoms will vibrate more and cause the increasing in scattering atoms.
Okay.
Okay. And then so after that, if the temperature increase, the conductivity also increase. but the resistivity will decrease.
Because of
The conductivity increase because of the scattering atom, the movement of electrons.
scattering makes the conductivity increase.
They vibrate, it's vibrating
Kau
more.
baca kat mana tu? Where did you read it?
Google.
You sure that's correct?
Yeah.
We talked about last time in class, when we increase the temperature, there will be lattice scattering, hence the mobility will decrease, therefore conductivity will decrease lah. How come the conductivity will increase?
I don't know. It said that when temperature increase, the conductivity depends on the number of holes electrons per mobility.
Okay, yeah, so it means that the free carriers increase, but in terms, because you are talking about the atoms vibrating, if the atom in relation to the atoms vibrating, it's that you increase the lattice scattering. Lattice scattering reduces the mobility, hence the conductivity. So there are two things there. When you increase the temperature, there are two things that will happen. Number one, decrease in mobility. Number two, increase in free carriers. We talked about this before in class. Therefore, the overall result will depend on which one is more dominant. Is it the mobility or the number of free carriers? We talk about this if it's doped material, then the the mobility will be dominant, because doping you already have a lot of free carriers even at room temperature. So we discussed about this last time. Okay, next question. What's the next question?
How does resistivity change with temperature?
So the answer is? Yes.
Yeah, if the temperature increase, the mobility will decrease, as well the conductivity will decrease. Then the resistivity is opposite conductivity, which means increase.
So it depends. If it's a doped material, it will be just the opposite of the conductivity that I mentioned. Resistivity is just the opposite of conductivity. It's the inverse of conductivity. So it depends again if it's a doped material or not. Okay, final question. What's the last question?
Resistivity with doping.
Okay, who wants to answer that?
Can I try though?
Yes, Nasri.
When we dope a material, the number of free carrier increase, so the mobility will increase, then it will lower the.
Jangan laju sangat, nak payah.
When we dope a semiconductor, the number of free carrier will increase. Then the mobility will increase, which will result the lowering the resistivity.
What is mobility? Mobility, why does mobility have to do with the number of free carriers? Ada benda yang kurang segregate di situ. It's not maybe partially right. Okay, you want to correct that, or someone else wants to answer? Mukminul, you answer. Because you've been reading about semiconductor, right? So let's listen. Let's hear from you. We cannot hear you. Something wrong with your mic. No voice at all. Okay, now. So continue. No voice.
Hello.
Okay.
Prof, can
Yeah.
hear me?
Yes, can hear now.
In the resistivity, the doping, if the doping is increased, the conductivity of the semiconductor device creates an hole and extra carrier to the hole and carrier to the dependent that is depending on the dopants.
Can you answer that again in one sentence? Everybody listen carefully and you tell me whether you agree with him or not.
Yeah, in the resistivity, if the doping, if the increase of the conductivity of the semiconductor, if the increase of the conductivity in the semiconductor device, it creates an extra hole or extra electrons to the dopants. And doping
Can you
can.
say it again with a clear English, brother? It's difficult to understand. Make it in a clear English sentence. Don't like jump here, jump there. Again?
If the
because it's difficult for us to get the points. At least me, I don't know. Maybe somebody else understand you.
If the conductivity of the semiconductor device is increased by doping, it creates an extra hole or provides an extra electrons on the dopants.
No, the question is, you need to answer the question. What happens to the resistivity if we increase the doping? Okay, then let me know.
If we increase the doping, the number of carriers and the conductivity of the semiconductor will be reduced. If not, we are adding.
Can you repeat that sentence again?
If we increase.
Brother?
Oh, cannot answer. I think my answer is not correct what I have written.
Macam mana ni? How Mukmino? Okay, who else wants to help? Mukmino, you need to read more. The rest? Answer. What happens if you increase the doping to the resistivity? He's actually on the right path, but I want to be here clearly, Mukmino. So you need to be able to convey your message clearly. I'm not saying you are wrong in the first place, but it's not clear, and I'm very precise. So if I'm not clear, I cannot say it's correct unless I can hear everything and understand everything that you say. Okay, who wants to answer?
Can I answer?
Yes, also.
Okay.
Doping means like increasing free carriers. If free carriers increase, the conductivity will increase, thus resistivity will decrease.
Why why the conductivity increase with doping?
Because generation will happen. Doping is adding impurity to pure semiconductor, means adding more free electrons or free holes.
Because conductivity increase proportionally with the number of free carriers, right? So therefore conductivity increase, therefore resistivity decrease. So you can change the conductivity or the resistivity by playing with the doping. Okay, good. So we answered all questions. So so what's next? Let's see our.
Can I add something?
Yeah, sure.
I have read that when we dope the material with too much of dopant, the resistivity will increase. Why?
Good question. Anybody wants to answer? I like that question.
I think it depends on the number of dopant, like how much will do.
Yes, that was his question, but sister, the question is why?
Oh, I think if it's that is a normal dopant. If it's too much, if we add too much dopant in the material, I think it will the resistivity will not change. Maybe. Like it depends on how much.
Yeah, I know,
Yeah.
sister. Yes. You need to listen carefully to what he said. He said, say it again, Asrin. And everybody listen carefully.
When we dope a material with too much dopant, the resistivity will increase. But why it happened?
So the statement is it increased. So there's no like, so to a certain value, yes, is it very high. Doping, then the resistivity will increase. The question is why. Anybody?
Maybe mobility depends on mobility.
How?
I think.
How?
Like if we like if it's too much doping, maybe the mobility will decrease. Thus, they can.
Why?
It become packed. Too many atom, too many electron.
Answer yeah, okay, I can understand, but answer in more physics, like academic physics. That not jawapan pasar malam, which is saya faham kau jawab pasar malam, tapi now we want to answer in the exam or quiz, so that like it be accepted as a good answer. So anybody, so Haziq was right, but I want it to be in a good term, semiconductor term or physics terms. Which we already learned in the class. I will not ask you question if I think you cannot think, and I don't teach you yet. Anybody? Fatin? Quiet, you're tired because of fasting. Fatin, what's the answer?
When there's an increase of doping, the concentration of the free carriers, the charge carrier increases. Like there will be a lot of electrons and holes. So that will decrease the mobility.
Why?
Because it will be difficult for
electron hole is very small. So if it's a lot, that doesn't change much.
Velocity.
You know the comparison of the size of electron and the atom, right? You know, right? It's like the comparison of, you know the comparison, the size of the Earth compared to the Sun? How many times? How many times? Google now, everybody. The size of the Earth compared to the Sun. And tell me. If the volume was okay, like when you talk about size, the volume or the size, the diameter, you know.
109 wider than Earth.
109? 109 only? You sure?
Times Earth.
Only 109? Are you sure? The size?
Yeah.
Anybody else with another answer?
1.3 million.
1 million.
1.3 million Earth could fit into a sun.
So I think something wrong with you, Adwa, or your answer, or your Google, or your or the site that you go. Haziq again?
1.3 million of Earth could fit into a sun.
Yes. So it means that 1.3 million of the size of the sun bigger than the Earth. Okay. So 1.3 million. So can you imagine? So can you imagine that how big is the sun? Can you imagine how big? Okay, next question. How big are we in relation to the Earth size? As a human being.
Tiny particles.
Like how tiny is the particle? So it's like we are like nothing. So can you and then compare you with the sun? Washamsi waduhaha. Allah, swear by the sun, because the sun is like, we see it on earth, like if you look outside there, not so big, but it's like how many million times bigger than the earth. And can you imagine how billion times bigger than the human? But still human being thinks think they are powerful to ignore what Allah says. So as simple as that. So to answer Fatin's question, the electron compared to the everything, electrons compared to the atom itself, to the nucleus, is very, very extremely small. Like we are like the earth compared to the sun, roughly. So it doesn't affect much. Okay. So who wants to continue answering? So that's why, sometimes we should reflect ourselves. Sometimes we want to ignore what Allah says. Human being want to ignore, don't want to follow what Allah says. Even to the sun is one of the big creation of Allah, right? Creation of Allah. But there are many more, Allah said, creation of Allah which are more majestic compared to the sun. But even the sun itself is something that we cannot comprehend how big and how majestic it is. So it just, that's why Allah says, the human being, manusia, the human, they just are heedless. They don't know what they're doing, and they don't know what they're thinking, and they are ignorant because they don't know how small they are by thinking that they are really big. So that's why learning science, learning engineering or science should make us closer to Allah. But no, we become smart and we feel that we are better than the religion itself. Something wrong. Sometimes we feel I'm better than this person or this person by learning engineering and science. The right thing is, if you learn science and engineering, you feel how small you are. And then you feel like, okay, I'm nothing, therefore you will not be arrogant. That's how it's supposed to be. Okay, so who wants to continue to answer? So what happens? What was my question to Fatin just now? Why? Why? Nasrin question. Thank you, Nasrin. So who wants to answer to Nasrin? You can answer your own question.
As we add the doping atom, the
dopant atom,
the lattice structure becomes so packed, then the mobility will decrease. So it will increase the resistivity.
So why does the mobility decrease? Because of what process?
Doping. Okay.
The mobility decreases. The doping, the process that makes it pack is doping. Make the lattice pack. What is the process that makes the mobility decrease?
The generation and recombination. Yeah.
Can I try? Lattice scattering?
Yes, the answer is lattice scattering lah, brothers and sisters. We done this last class. So penat saya ajar last class. Awak ni semua faham ke tak tahu, So I'm just saying also, I teach, I hope everybody understand when I teach the class. So the thing is lattice scattering. Scattering, if it's too much, if it's too packed, I draw last time that the atom can be, if it's too packed, it will not be in a regular array. It will be like push in the lattice. So it won't, you will create defects, number one. And number two, it will also gives this scattering, increase the scattering, therefore reduce the mobility, therefore increase the resistivity. Okay, any more question? No? Okay, we continue. So where should we continue? Badrul, you okay?
Okay, ada.
Oh, tak datang kelas sebelum ni, boleh catch up ke?
InsyaAllah.
Okay. InsyaAllah. Semua I really hope that insyaAllah is real, insyaAllah. Otherwise you learn from others. Kat sakit awak sebab tu. Sebab I'm worried when you kau tak sihat. I don't want to get COVID. So anybody with a symptom are banned from going to the class unless you show a letter that you are perfectly healthy. Okay. So kat mana recent? I'm trying to open some slide. This is not the slide that I want. This is from mana? Open. How do I open this new system? Open. I drive. Slides. Okay, I think we are on slide 2. Is it slide 2 or slide 3? Anybody knows? We are on slide 2. Okay, so let me share now. We talk about mobility, we talk about conductivity. Now, let's talk about diffusion. This is very important. You don't understand diffusion and drift, you will not understand everything on PN junction. And if you confuse about diffusion and drift, you'll also be in trouble for the rest of the PN junction and onwards. Because there'll be a lot more on drift and diffusion. So let me open my notes. Any more questions before we continue? No? Okay. Now diffusion. Okay, diffusion. So what is diffusion? Okay, what is diffusion? See. Stop sharing. This is my slide. Ada ke dalam slide ni? Okay, maybe I will share this. I will share the slide first. So, okay, brothers and sisters, there are two main current mechanism. Okay, two main basic. Basic is the lowest level. If you don't understand this, let's not talk about the high level conductivity, especially those who are doing research in this area. Who do research in this area, this is the basic that you need to know. If you don't know about this, if you talk about others and you don't understand this, it means that you don't understand how to do the research. So there are two basic main current mechanisms. I mean, how current flows inside a semiconductor material. How current flows, there are two basic mechanisms. One is called the drift current, the other one is called the diffusion current. Okay, so this one, the jam. Lately, I have a problem on my laptop, like they hang. I don't know. Okay, drift current. So let's first talk about drift before we talk about diffusion. See, it doesn't want to go to presentation mode. I will report a new by waiting for the new laptop to arrive. I cannot work like this. Okay, so drift current. So drift current and drift current density. You know what's the difference between current and current density, Nasrin? Badrul, listen, because you weren't here last class.
Current is the net flow of electron. Current
Per?
density,
Per?
net flow of electron.
Per?
That's for current. Itu.
Over
Per over
Per
time.
time. Over time.
Or unit times.
Okay, that's very important. Otherwise, you got it wrong.
Okay.
Again, repeat.
Current is net flow of electron per unit time.
Hmm.
And then density is current over area.
Okay, current divided by the
Area.
cross-sectional area.
Area.
Okay, so that's the difference. So Badrul, take note. Now, so as I mentioned, in the semiconductor material, there are two types of basic current mechanism. Now, one is drift. We talk about this roughly when we were discussing last class. So drift, in order for drift to occur, there must be an electric field. So the keyword for drift current is electric field. Whenever you have an electric field, the current the current mechanism is drift current. It means that the free carriers that flowing inside the material to constitute to the current is moving due to the electric field. So we talk about electric field. What is electric field? Adwa?
Current that move in
Electric
close
field. Electric field, brother. I'm asking you electric field. I'm not asking about current. I'm asking about electric field. Which I also taught last class. Somebody else, what is electric field? Madam, do we need to remember everything that you tell us in the class? Yes. We cannot miss one
Voltage
thing.
over distance, madam.
Yes, what is it?
Voltage over distance.
Yes, electric field, you got the electric field when you have a voltage and it's across a distance. That is electric field. So whenever you apply a voltage and there's a distance, that's electric field. So when you have electric field, this will force will force the electron to move to in a certain direction and also holds, right? So if you look here, the electron will flow in the same in the opposite direction of the electric field. So the hole will flow in the same direction of the electric field. Electron will flow in the opposite direction of the electric field. So if you have and this electron and or free carriers that flows, it will have a certain velocity. Okay, the velocity of the electron or the hole, it depends on the electric field. If you applying a higher voltage, applying a higher electric field, it means that the velocity will increase. Okay, so the drift, we call it the drift velocity. And this drift velocity is the unit is centimeter per second. Is a function of the electric field and the mobility. If the material is the same and we change the electric field or the voltage, it will increase or decrease the velocity of the carriers. Why is it important? Yes, it's important. It depends on, as I mentioned before in the class, the application that you want to use. If you are you want it for a high speed application, so this is important. You need to look at the voltage, the field, electric field that you are applying it with, the working voltage that you want it to function. So therefore, so this we talked about this equation last time about the current density is a function of the E is the electronic charge, N is number of free carriers. So if it's this is talking about electron, and then the number of free electrons times the velocity of the free electrons. So drift current can occur due to both. So as I mentioned, in semiconductor material, you have two carriers, electron and hole. So electron will have its own drift current. Hole will have its own drift current. So the total drift current will be the sum of the electron and hole. Okay, because both can flow and both flow with different magnitude. Okay, electron and hole current density inside the same material will have different current or current density. because of the different mobility. In mobility of electron and mobility of holes are not the same. Anybody knows why?
Because the mass is different.
Good. Because of the mass is different. So which one is heavier, electron or hole?
Electron.
Siapa jawab tu? Who's that?
Hole, madam.
Okay.
Ada lah jawab hole. Ada jawab electron. The answer is hole. Hole is heavier compared to the electron. Okay, so they're slower in terms of moving. So when it's fat, when you're a thin person having a race with a fatter person, the thinner person will win the race. I remember the story of Aisha and Rasulullah SAW. You know the story of racing between Aisha and Rasulullah? Nasrin? You my favorite student for today because I like your question. So, Nasrin?
There's one time yang Rasulullah saja buat kalah tu kan?
Bukan dia saja buat kalah, tak ada makalah. Awak ni apa saja.
Tak sure itu.
Anybody else? You don't know the story of the Prophet? You know who's Aisha?
Yes, madam.
Yes, madam.
Who is she? Who is she?
Daughter of Abu Bakar.
And who is she? Most importantly?
Wife.
Wife of
Wife.
Yeah, the wife of the Prophet Muhammad SAW. So Asma also daughter of Abu Bakar, but not the wife of Rasulullah SAW, right? So when Aisha was young, she is still thin, you know. So she had this. Sometimes Rasulullah SAW will play with Aisha. They were running, and Aisha wins when Aisha was like younger. So as the years goes by and Aisha got older and heavier, so they had the race again, and then Rasulullah SAW won. So going back to this electron hole is heavier compared to electron. Therefore, the mobility is less for hole compared to electron. That's why that's another thing. When we want to design a semiconductor device, we can design it based on what is the majority carriers that we want. So if we dope it with it becomes n-type, the majority carriers are electron. When we dope it with hole, p-type, the majority carriers are hole. So therefore holes move slower. The velocity, if the same electric field, comparing electron hole is slower. So therefore, if you want high speed devices, maybe you want to consider electron instead of holes. Okay, so electron and holes have its own mass. Therefore, it has its own mobility. Therefore, the current, the drift current will be different from electron and hole. So, but the total drift current inside a semiconductor will be the contribution due to the electron and the contribution due to hole. Nanti kat mana? Maybe the next page. Here. See, the total of the current, drift current will be due to electron and will be due to hole. So the difference is on the number of free carriers of electron hole and also the mobility. The electric field is the same because we are applying across the same semiconductor. Okay, so what is the drift current? Drift current is current that moves inside the semiconductor due to the electric field that we apply across the semiconductor. So whenever there's an electric field across the semiconductor, you have current, and the current is called drift current. Okay, and it has a certain velocity that you can calculate. So for the, as mentioned, for the hole is the opposite of the electron. So if the electron, the electric field in this direction, the hole will move in the same direction. So the current is the same direction of the hole. So that's it. Okay. Now Okay, that's you understand, but there are two main. Number one, I already explained about drift. Now the second one, which is the diffusion current. Yeah, this one should be diffusion current only at the top. So what is diffusion current? So diffusion current is flow of particles. Particles mean the charge carriers from a region of high concentration to low concentration. If you can still remember your experiment during, during SPM, A levels or O levels, you have this experiment where you put gas, gas, high concentration of the gas and low concentration of the gas. And then you put it together, what will happen? The molecules of the higher concentration of the gas will move to the lower concentration, right? That's how it works. So similarly for carriers, for electron holes, if you put two regions together, one with the high, high concentration, the other one is with the lower concentration. What happens is this from the high concentration carriers will flow into the lower concentration. So that's and this mechanism is called diffusion. And this mechanism is called diffusion current. So number one, you can get current when you put electric field. But if there's no electric field, but there's difference in concentration of the free carriers, you can also get current. And this is called the diffusion current. Okay, and from high to low concentration. Remember. So again, diffusion current can be both due to the electron holes, and the equation is like this. The current density is the electronic charge times the dn. Capital D here is the diffusion coefficient. So different material will have a different diffusion coefficient. So you can Google this for this information is everywhere. But the diffusion coefficient again different from electron and hole. So it has a different diffusion coefficient because of the mass as well. And also the different type of material will give you different diffusion coefficient. So meaning silicon and germanium will have different diffusion coefficient. So it depends on the material. Okay. It's mentioned mobility just now, also depends on material. So so different material will have different mobility. And then multiply by the concentration gradient. So dN over dx here is the concentration of the free carriers. So the more difference in the two material concentration, the higher will be the current. Okay, so these are the three. This is just a constant. Two main parameters that you need to consider for diffusion current. So so similarly for the whole, the what do you call it? So maybe you need to mute yourself, Inul. I can hear the background noise. Okay. So apa saya nak kata tadi? I get distracted easily. That's my characteristic. So what I want to say here, the direction. So electron will move. So for diffusion, you need to look at the where's the high concentration and low concentration. It'll always coming from the high to low. So electron will also go from high to low, and the hole also from high to low, both. But the current convention is still the same. Whereas if the current is the opposite direction of electron movement, and for current for hole is the same direction of the whole movement. So that one you need to always bear in mind. Okay. So hole will also have similar current density. You have the diffusion coefficient for the hole times the concentration gradient for the hole. So the total, I didn't write here. So the total diffusion current will be a sum of the Jp and Jn. The diffusion current due to the hole and diffusion current of the electron. Okay, any question on drift and diffusion current?
How do we know if is it high or low concentration?
You answer that question.
Macam mana Madam?
You answer your own question. You should be able to answer it. Other people? It's a very obvious question. Nobody can answer.
We see if there are many electrons there, so the
No,
there
how
is
do you
high
see? You cannot see
concentration.
with your eyes, brother. Cannot.
Wait. We use the formula to get the electron.
Based on the
density.
graph, madam.
Huh?
Based on the graph,
What graph?
itu yang whole division tu.
Apa? Which one? This one?
Yeah.
No. The answer is from doping concentration, brothers and sisters. The one normally what we know is the doping concentration, right? The higher the doping, the higher the number of free carriers. If you have the doping concentration of electron, ND, I will say is a carrier, donor atom. Donor atom, number of donor atoms or concentration of the donor atom constitute to the concentration of the electron. Therefore, the same as number of free carriers per unit volume. Betul ke tak betul? So we know the doping. We can test the doping. Can you check the doping, Haziq, from experiment?
Yes, we
Yeah,
can.
we can do some experiment to check the doping, the number of doping concentration. So that one we can know. Normally in the question, the exam also, I will give you doping concentration, but I won't give you number of free carriers because normally we don't do that. We from the measurement in the lab, we will get the doping concentration. Okay, any more question? No? Okay, apa lagi kita nak cerita? Now we're going to PN junction. So we understand everything. Okay, brothers and sisters, this is the important part. Okay, this is the important part. What time? 4:25. We're supposed to finish at 5. Okay. I will draw. So I think so PN junction, now we finish the semiconductor basics, physics. Now we want to go to semiconductor material. Now we go into device. So we just started our course. Our course title semiconductor device, right? So, but if you don't understand the semiconductor material, you will not be able to understand semiconductor device. So material is the basics. We assume that we cannot assume. You forgotten already your first year degree. So that's why we have to use like few weeks just to brush your fundamentals. Okay, now we go to the device. Okay, so the most basic device that you can have, the most basic, the most simplest, the easiest. Okay, the easiest I'm saying. So the easiest, the most simplest device that you can have is semiconductor. What we call it the PN junction. That is the simplest, the easiest. So if you don't understand the easiest, let's not talk about BJT or MOSFET. Okay, it will be more complicated compared to the PN junction. So this is the basic to understand the rest of the course. Okay, now I will just draw. And this is where hopefully it gets more exciting lah. At least to me. To me, semiconductor is always exciting. I don't know about you. So, okay, so. So that's why people sometimes looks weird to the scientists and engineers or scientists. They're happy with what they do. It's true. Sometimes they, you know, you look at some scientists, they even sleep in their in their lab. They will sleep in their lab. They'll be thinking 24 hours of their research, of their the theory. Why they do that? Because they are, of course, they are passionate. They love what they do, so they will spend. It's like hobby. So the same with this. So with me and semiconductor. But the thing is, you need to understand first. That's why brothers are, especially those who are doing research in this area, make sure you understand. Otherwise, you instead of finding it interesting, you'll find it like a hell because you don't understand anything. You read that, you don't understand. You read this, you don't understand. So then you will just suffer. But these few these few classes is very important so that you will understand the basic of it, so you can move further. Otherwise, you cannot move. Okay, you just memorize, and when you started to memorize, then everything will go downfall. PN junction. What is PN junction? Anybody? You learned this in your first year degree, first class. Not first class, first year. Sorry. Anybody? What is PN junction?
As I remember, it's N-type and B-type together.
Okay, then?
This is 2 semi.
Yes, continue. Who else?
These 2 semiconductor material that are namely P-type and N-type inside a semiconductor.
You need to speak clearly, brother. I have problems understanding your English. You need. It's not your English.
The PN junction is the interface of
Pronunciation.
the PN junction is the interface of a semiconductor material that is namely P-type and N-type inside a semiconductor.
Say it again.
It is mainly the semiconductor material that is namely P-type and N-type that is inside a semiconductor.
What is a PN junction? Explain again. No, normally when I ask you to repeat many times, it means that I don't really understand what you're trying to say. Can you say again? Make it clearer, brother.
The PN junction is the interface of between the semiconductor material that is P-type and N-type inside a semiconductor. Can you hear?
Yes, but your sentence is like, you need to make it clear your sentence. Can you write down your answer and then tell me again? Write down. I need to what do you call it? I need to train you to be able to communicate effectively. Because one thing about being an engineer is to be able to communicate clearly so that people will understand. Sometimes maybe you understand, but you need to make other people understand clearly. Can you write the sentence and then put in the chat, Mukminul? The rest, anybody else while Mukminul write the sentence?
PN junction is a two-terminal device in the semiconductor. P is referring to the anode and N is referring to the cathode.
Okay. Okay. So PN junction, the name comes from the word junction. Okay, what is a junction? Junction is when something meets something, right? Two streets, jalan, two streets meets, and there you have a junction. So junction is about something meeting another something. So junction is, so PN junction is a junction between P and N. If you have only these two very simple, what do you call it? Material, then you will get a device. Okay, so the most basic is, number one, you need to have a P-type over here. You need to have N-type. Okay, my first question, the P and N, can it be the same material or it can be different material? P and N.
Can be the same.
Huh?
Can be same.
Different? Possible or not?
Possible juga kot.
How? Give me example. We learned this already in class. What does it call?
Compound semiconductor.
Compound two is one semiconductor.
Heterojunction?
Huh?
Heterojunction.
Oh,
Thank you, sister. Heterostructure or heterojunction. Heterostructure or heterojunction. What is compound semiconductor? It's just one type of semiconductor, brother. Jangan tertukar. Don't mix up. Compound semiconductor is just one semiconductor. There's no junction. It's just one. It's one seketul, one entity of semiconductor material. So, but it consists of different atoms inside the compound semiconductor, but in the end, it's one semiconductor. But when you talk about junction, there are two semiconductor material that you put together. And these two semiconductor material, it can be from the same material, or it can be from different material. So if it's the same material, we'll call it homojunction. If it's different material, we'll call it heterojunction. Okay. Now, so let's make our life easy here. We are all, beginners. So let's have a homojunction, both silicon. Silicon of P-type and silicon of N-type. So one side is we dope it with P-type, another we dope it with N-type, and we put it close together like this. Okay. Now next, so the question is, what will happen inside this piece of semiconductor device? Anybody wants to try? Using the knowledge that we learned before in the class. What is the most obvious thing that you can see here?
When the P-type is more whole.
Okay.
When the N-type is more electron.
Okay, then what?
Then when we connect to the circuit,
Not connect circuit, when we connecting the two, we put together the two, right?
It will attach.
It's already attached, brother. Here, junction attached. Then what happened? We just talked just now in the class.
Diffusion.
Huh?
The high
Yes.
concentration.
So can you explain what happens again, Fatin?
The high concentration, the carriers will move from high concentration to low concentration.
Tell me from where to where? Here.
From N to P.
Okay, repeat again your sentence.
The carriers.
What carrier?
The electrons will move from N to P.
And?
From high concentration to low concentration.
Okay, that's all? Is that all? What else?
Holes also will move to N.
Repeat your sentence clearly.
Holes also will move from P junction to N junction. Yeah, because we know that in P-type material there will be extra holes. So there is high concentration of holes in the P material. It will go to the N.
Okay. All right. So yes. So number one, there's a difference in carrier concentration. So you should notice the P and N. So yes, correct. Number one, that will happen inside a PN junction. So number one that will happen is diffusion. But you need to be able to explain what does this diffusion here. So it means that electrons are diffused. Use the word diffuse, don't use move. Why? Because diffuse come with a very specific and technical term. When you say diffusion, electron diffuse, it means that it has a diffusion coefficient, and there's a gradient, different concentration gradient. So I'm very sensitive to the terminology, because from many semesters I notice the student is not, they sometimes just move, jump. Yes, it's okay, but sometimes you need to be more accurate. So the electron will diffuse from the N type to the P type, and hole will diffuse from the P to N because of the difference in concentration gradient. Good. Next, what happens? You also know this. We learned the basic already. So after they diffuse, then what happens? Okay, you need to imagine, sisters and brothers. So this electron, they are here. If the electrons are here, no problem, because we have a majority of electrons here. Now the electrons goes over here, which then the electron becomes here. Okay, so my question to you, this electron that diffuses into the P, okay, this electron here, is it free or bound?
Free.
Bound.
Huh?
It's free.
Who answered that? I cannot see. Siapa jawab?
Aziz.
Okay, correct. So it's free. Because yeah, it's just moving, it just move from here to here, of course it's free. So this electron here is free. In this p-type side, what do you have? A lot of what?
Holes.
A lot of holes. And this hole, is it free or bound?
Bound. It's bound.
Kena tembak awak ni. Think again. This P.
Extra holes. P extra holes bound.
Oh, salah pun nak masih menegakkan benang yang basah, nak kena dengan saya. So it's wrong. So who here wants to answer? Amirul. So you have a P, you have holes over here. Is it bound or free?
Free, madam.
Why is it free, Amirul?
Because in P type we have a lot of free carrier, which is hole.
Correct.
Free carrier.
Yes, of course, nama dia pun P-type, because P-type, it generates free carriers, free holes. So now let's go back. So this electron, free electron, now it diffused to the P side. So now in the P side, there are a lot of free holes. What happened next?
It diffuse to N type.
We talked about this before. So that's why I said everything that you learn from first day of the class, you cannot not remember. We'll be using every single thing that I taught in the first class until now. So what will happen if the free electron meets a lot of free holes? Anybody? Give me some, good tidings in the second day of Ramadan that you remember what I teach, what I taught. What happens? Also, I hope that you remember. You are my go-to student. Yes, also. What's the answer?
I still remember.
Okay. Who do I need to rely? Anizam, I hope you can answer.
Recombine, madam.
Yes, the answer is recombination. Why you all forget? Okay, free electron, when it meets free holes, it will recombine. Okay, so the second step that will occur here, brothers and sisters, is recombination. Why? Because these free electrons are meeting free holes inside here. Okay, so can you imagine the electrons that goes here now recombine with the holes? What happens at the area that the recombination occurs?
Depletion region.
How do we get the depletion region? Why? If you understand, you're able to answer. If you memorize, you cannot answer.
Because due to the recognition, the host and electron disappear.
Okay, so after it disappear, it leaves what?
Depletion region.
Energy.
What is depletion region?
The amount of electron and host are at equilibrium.
No. What is depletion region? Mukminul, do you know what's depletion region? Mukminul, you there? Mukminul, can you hear me?
Yes, Prof.
You know what depletion region is? You know or you don't know? Just answer yes or no.
No, Prof.
Okay, somebody else answer what is depletion region? Don't know. Everybody don't know.
Depletion region, I think, it is the region between P and N junction. When the electron recombine from N type to P type, it will create a depletion region.
I know. There's a memorized answer. What is the actual the depletion region? If you answer that to other lecturers, they will accept it. But if you answer, the problem is you are answering to me. So I don't know. It can be maybe a curse you have me as a lecturer. But I will want to know whether you understand or not. Okay, I will tell you. Depletion comes from the word deplete. What does deplete means?
Resist or oppose.
Less.
I cannot hear you.
Resist or oppose.
No, that's wrong. Mukminah.
Reduce.
Yes.
Reduce less.
Reduce or less. Yes. So reduce or less. That's deplete. When we say something is depleted, it becomes reduced or less, right? Or losing something, right? That's depletion, depleted. So the name from depletion region, it comes from, okay, brothers and sisters. Now let's go to another physics. So I told you, right, this class is full of physics. I already warned you, brothers and sisters. It's back to our atom. Okay, can you see my atom here? So atom here. So you can see my atom here. So this so if this let me say it's a silicon atom, we have 4. Right. These 4 electron at the outer electron. Is this what is the charge of this atom? What is the charge of this atom? This is basic A levels, O levels, SPM question. See, we have to go back to our SPM. So if your SPM is strong, we can do this. If not, then if your A levels, O levels are not strong, your degree is not strong, we'll be having problem. So what is the charge of this? Badrul, cubalah.
Positif.
Siapa jawab positif?
Saya, Haziq.
Badrul, what do you think? We go back to you, Haziq, after this. Macam mana apa jawab positif? Badrul?
Negatif.
Badrul negatif. Haziq positif. Let's hear from Fatin. Engineer Fatin to answer, yes.
Negative.
Oh, Engineer Fatin answer negative. You all will graduate, right? Okay, Nasrin. Nasrin, answer.
Negative.
Negatif apa itu?
Negative. So also answer negative. Anizam, Mukmino, the rest of you answer.
Positif. madam. Neutral ke madam?
Okay, we have one answer neutral. Why, Amirul? At least we have hope in this class. Huh?
I'm just
Me too, madam.
because
Amirul.
because you say negative is wrong, positive is wrong, so maybe it's neutral.
So you're guessing, you don't even know. So
4 plus or 4 minus, madam.
huh?
4 plus or 4 minus.
What do you mean by 4 plus or 4 minus?
The charge for silicon.
Can I try?
They can
Can
attract,
be both.
can attract or can donate
I'm asking the charge of the atom.
charge.
The whole atom, what is the charge?
No charge.
Why no charge?
Because it doesn't
It doesn't bind with other atom.
It doesn't attract any more
because
atom.
it's already stable.
Yes, for
What does
equivalence.
it mean already stable? At least you're going somewhere on the light, you know. We are not going to darkness now. Okay, so we are moving, although not getting the answer yet. So what does it mean stable?
Stable mean it can lose or accept electron.
Wrong. So we're going to the darkness again. Anybody else wants to bring us to Ihdinas Siratal Mustaqim? Let's go to the right path. Now we're going to the wrong path. Anybody?
Because it already has 4 valence electron.
So
Stable. Because an element can be stable if the valence
I
electron
know, but we
is
are talking in terms of the charge. Because Adwa saying is zero charge. The answer is yes, zero charge. It's not positive, it's negative, it's neutral, zero. So the question is why? Anybody? SPM level? Anybody got an A for physics here?
This is chemistry.
This chemistry? No, this is physics, atomic physics. You Neil Bohr, you learn in physics, not in chemistry.
Okay. Because it's not iron nice.
What does it mean?
Because
Contains the same amount of positive and negative ion.
Not accurate, Mukminul, you are going there. Still, we are going to the light again, but not right 100%. Still wrong. There's something wrong there. Be careful of the terms that you use.
Same number of proton and electron.
Okay, we maybe we are on the light, so elaborate a bit more, Fatin. Why is it neutral?
Because it has the same number of protons and electrons.
Therefore,
it's neutral.
yeah, the number of protons have a positive charge. Electrons have a negative charge. When the number of the protons and electrons are the same, the atoms are neutral, brothers and sisters. So that is the normal atom in the periodic table. It's neutral atom, all of them. Okay. So because the number of protons, Allah created very nicely. The number of protons equals the number of electrons, therefore it's neutral. Now, so we die. So we just started here. Now we want to understand depletion here. So what now? Now we understand this is neutral. Now we have a neutral atom at this side. Suddenly we have recombination. What happens to the neutral atom?
It will guide.
Huh? Will what? What happens to the neutral atom? What happens when recombination? What happens during recombination?
We will release.
Excited.
Huh?
Excited electron.
Loose charge carrier.
Loose lah. Kenapa release pula? Senang nangis saya ni mengajar. So we are losing free carriers, right? Recombination. Okay, so here in this area here, what are the in the atom? What are the carriers that we are losing?
Electron.
Ada seorang jawab electron, another answer hole. So what's the answer? The right answer? Electron or hole? Okay, you only have two choice. You don't have proton. If you answer proton or neutron, we back to first class. So what do we lose? Electron hole over here in this region here.
In this region, hole.
Holes.
Holes, madam.
Holes, you sure?
Electrons.
Sebab dia jadi natural kan?
Natural. Stress saya. Okay, stop your answer electron. No, okay, brothers, this is not magic. This is physics, which we can understand. You need to use your logic akal. The akal that Allah has given you, brothers and sisters, is not there to just memorize. When Allah gives you akal in the Quran, Allah afala ya'qilun. Do you not think? Use your akal. This is where you need to use your akal. So if you have an atom, and then it's neutral like this. Very nice. Okay, very nice. Then there's a recombination process that occurs in this region, which means that you will lose free carriers. So in terms of this region over here, the atoms here. So if I have to draw the atoms here, the atom here, which is neutral to start with, although it's p-type, but it's neutral. Although it's p-type, but it's neutral. I repeat, it's p-type, but it's neutral because the number of the holes and electrons is the same number of the proton, so it cancels out. So it's neutral. But now, in this region over here, suddenly you have recombination due to electron diffuse, which means that you are losing free carriers. What is the free carriers that you lose over here? Is the one of the P, which is the hole. So you in the atom here, what happens to the atom over here? It just realized, oh, I lost a hole, right? Because the hole are being recombined by the electron here. Now my number one question, what happens to the atom? What is the charge of the atom now after recombination?
Should be negative.
Huh?
Negative? Should be.
Why?
If because free carrier in P is the hole is free carrier. If it loses, means it's negative.
Yes. So this atom is neutral. When you lose a hole, which is a positive, it becomes negative. Okay, so what is left here? Make sure you remember and you understand this. You know why, brothers and sisters, this concept I can use in any of semiconductor devices. It will crop out here and there in a different question, but the concept is the same. Okay, I'm only warning you because many students don't get it. So the answer is, what is left here, brothers and sisters, are, so maybe I will draw it bigger like this, is the atom but the atom is no longer neutral. So it becomes here positive or negatively charged?
Negative.
Negatively charged.
So what is left? Wherever you have recombination at this place here, near the junction, because the electron will meet near the junction. So whenever the electron comes here, meet free hole recombine, meet free hole recombine, meet free hole recombine, meet free holes, it recombines, and what is left is ion. Ion is charged atom. Atom with a charge, which is not neutral, is called ion, brothers and sisters. So it can be positively or negatively charged ion. If you loses hole, then it means that it becomes negatively charged. Okay. Now this is one concept. The other one, remember we talk about the hole also diffuse to this side. So what happens to for this area here?
This is positively charged.
Positively charged.
Why?
Because the atom has more holes.
Yes.
And lose
You go step by
electron.
step. What is the process after diffusion here?
Recombination.
And then
Combination.
recombination will leave you what?
It will leave us more electron. More holes. Terbalik. Positively charged.
So this area here, recombination will occur, right? So the neutral atom becomes, will lose
Positively
what? Will
charged.
lose what?
We lose
The neutral-
electron.
It will lose electron, therefore it
Yeah.
becomes
Positively charged.
okay, positively charged. That's why. So now this area here becomes positively charged ion, and this region here, where we have ionized atom or ion, is called depletion region. Why? Why? Because it depleted of free carriers. So this in this area over here, brothers and sisters, there are no free carriers. There are no free carriers because the area are depleted of free carriers due to the recombination process. What is left is ionized atom. Okay. So you understand up to that, right? Any question? Because we are we are out of time. Any question? No question. Everybody understand? Are you sure? Okay. Huh?
On my way.
Who's on the way?
Adwa minta maaf. Dia macam
Yeah, okay. It's rendering, you know, it's like you know, in the computer, like it's like refreshing or buffering. So it's okay. Hopefully by the next class is stop buffering and it's already in here, inshallah. So next we'll continue what happened next. So if you want to save yourself from questions, you can go and read what else happens and why. Okay, so we haven't finished. This is no bias yet. We haven't add any bias, and we want to know what's inside and what makes the PN junction special. Okay, so we stop there with depletion region. Then we continue inshallah next class with the rest of it. Then after that we'll learn about forward bias, reverse bias, and then after that breakdown and so on. Okay, I think that's all for today. Can we have a brother to recite the doa? Jangan doa makan dah. Not the, you know, the eating. Brother, we cannot hear you. Can you recite clearly? With the pronoun, open your mouth bigger, brother. If you want one way of.
Allahumma amin.
Brother, I haven't finished speaking. Listen to me. You need to listen carefully and you need to speak carefully. You need to open your mouth so that it's clear. I'm not the only one who commented on this. Other people also commented that they cannot understand you. It's not that because your English is not good. It's just how you pronounce. Okay, so if you want to make clear, open your mouth clearly when you speak. Okay.
Allahumma amin. Rabbana atina fid dunya hasanatan wa fil akhirati hasanatan wa qina adhaban nar. Rabbana la takunna minal khasirin. Warhamna ma'hum bi rahmatika ya arhamar rahimin.
Even though with my comment you still the same. I don't understand Mukminul why. Never mind. Maybe I need to send you to a class, a communication class in the, you know, just to improve, inshallah. It's not communication skills, very important, brother. Okay, let's end the class with tasbih kifara and surat al-Asr. Subhanakallahumma bihamdika. Nashhadu an la ilaha illa anta nastaghfiruka wa natubu ilaik. Bismillahirrahmanirrahim wal 'asr. Innal insana lafi khusr illa allazina amanu wa 'amilus solihati wa tawasaw bil haqqi wa tawasaw bis sabr. Okay, thank you. See you on next class. Assalamualaikum warahmatullahi wabarakatuh.
Madam, password hari ni apa?
Okay, the password for today's attendance is Ashams. We talk about the sun. The sun, right? Ashams. Washamsi waduhaha. So Ashams.
Thank you, madam.
Okay, see you next class. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, madam.
Welcome.